Lewis structures. Now, I want you to pay attention to this. If you follow the experiment from the beginning till the end, it is as simple as saying, I have taught you Lewis structures already. So I'd like you to follow the steps from the first step to the last step. Now, experiment 8 is found on page what again? 80 what? Thank you very much. 82. Now, the very first answer question that says, for each of the following questions, writing Lewis symbols and structures, fill in the blank spaces with the Lewis symbols for the third period elements listed. Now, remember that the Lewis symbol of an element is equivalent to what? Placing the number of dots corresponding to that element's what? Group number. Are we together? So if an element is in group 1, you place how many dots? 1. Group 2, how many? 2. Group 3, how many? 3. Etc. etc. So therefore, we are done with question number 1. Yes, we're done with question number 1. So these are the answers. You have sodium, Na, you put what? A dot. Magnesium has been done for you already, right? The next one is what? Aluminum. Aluminum looks like this. You have dot up, dot, 2 dots by the side. The next one there is what? Silicon. It's been done for you already, right? Next is what? Phosphorus. I have a P here. You have 1, 2, 3, 4, and what? 5. All right, so that's phosphorus. The next one I have there is sulfur, which is in group 6. I have 1, 2, 3, 4, 5, and what? 6. All right. Now, the next one I have there is chlorine in group 7. I have 1, 2, 3, 4, 5, 6, and 7. I'm done with number 1. I'm done with number 1. Yes. On top, still the same thing, no problem. I'm placing it by the right because I am right-handed, okay? Can still place here if you are left-handed, or up if you are up-handed, okay? Or down if you're down-handed, no, whatever. Depends on what you want. Write the Lewis symbol for each of the following. Magnesium ion. Now, if you look at number 1, the Lewis symbol for magnesium atom is written there, right? That's magnesium with what? 2 dots. Is that true? So what will be the correct Lewis symbol for magnesium ion? It's going to be what? Mg 2 what? Plus. And that's all. Write it down. Fast. Mg2 plus. Why is it Mg2 plus? Because it has lost the 2 what? Valence what? Electrons. So that's the Lewis symbol there. Next, the Lewis symbol for argon. Argon is in group 8. So you're going to write argon, Ar, 1, 2, 3, 4, 5, 6, 7, and what? 8. Argon is in group 8, right? It's a group 8 element. So it has 8 valence what? Electrons. So you drop 8 dots around argon and that is all. Move on to the next. What's the next one there? Is iodide what? Ion. Now, iodine as an element belongs to group 7. So therefore, it has 7 valence electrons, which will look just like the chlorine you have here, right? Now, pay attention to this. Now, for it to be an iodide ion, that is I minus, it simply means it has gained an extra what? Electron. Now, this is how you're going to write it. So this is my iodide ion. I'm going to write I, 1, 2, 3, 4, 5, 6, 7, and what? 8. I'll enclose the square bracket and I'll put the minus where? Outside. That is all. That's the iodide what? Ion. Move on to the next one. Next one there is cesium ion. Cesium what? Ion. And then if you go to your periodic table, you discover that cesium is an element found in group 1. Group what? 1. It's found just before francium. Before what? Francium. It's a group 1 element. So cesium as an element can be written just like sodium. That is Cs what? Dot. But we are considering cesium ion, meaning that it has lost 1 what? Electron. So it will be Cs what? Plus. Are you following this thing now? Beautiful. Move on to the next. Alright, so we're now going to be considering the oxygen ion. The oxygen what? Ion. Now we all know that the oxygen as an element, we have the same Lewis symbol as what? Sulfur, right? They are all in the same group, right? You have 6 dots around it. Now, for it to be an oxygen ion, it simply means it has gained extra what? 2. So I'm going to have it like this. O, 1, 2, 3, 4, 5, 6, 7, and what? 8. I'm going to put a square bracket here. And what will I put outside? 2 what? Minus. Beautiful. Listen to this. Number 3 says, construct the Lewis structure model for the ionic compound potassium chloride using the following steps. Using the following what? Steps. Now, if you follow all those steps, you become very good with Lewis structures. Now, look at the step 1 there. Step 1 says, the number of valence electrons in a potassium ion. Now, let's answer the question first. Relax. How many valence electrons are there in a potassium ion? What's the answer? The answer is what? All of you are wrong. You are what? You are what? Wrong. The answer is what? 0. Now listen. Shh. Potassium is in group what? 1. It has 1 valence what? Electron. Shh. But for it to be a potassium ion, it has lost 1 what? Electron. At this point, how many electrons are remaining? How many? 0. I know it should have been somehow logical for someone to say that it has 8. Because if it loses that one, there's another outer 8, right? We are not considering the outer 8. So our concern is that it has lost the 1 valence what? Electron. So how many electrons are how many? 0. So the answer is there is what? 0. Write it down. Either write it in words, write it in, you know what I mean? 0, Z-E-R-O, or just O. Fine. Move on to the next. Number of what? Valence electrons in a chloride ion. Now listen. That be how many now? How many? 8. Write it down. 8. So number of valence electrons in a chloride ion is how many? How many is that? 8. Okay. It's 8. Fine. It's 8. Move on to the next. It's 8 there. Okay. So now the next question says, write the atomic cores for potassium and chloride ions. Shh. Look at the atomic cores here. Let me clean this side. Atomic core just represents the symbol of that particular ion. For example, what's the atomic core for potassium ion? Is what? K what? K what? Plus. What is the atomic core for chloride ion? Is what? Cl what? Minus. That's all. That's all. Just write it there. So the atomic cores don't usually carry dots. They don't carry dots. Just the symbols with the charges. Can we move on? All right. So next question says, write the Lewis symbols for each ion. Now listen up. Write the Lewis symbols for each ion. So what are the Lewis symbols for each ion? Now look at this one here. The Lewis symbol for this ion here is what? It still remains what? K what? Plus. Now what's the Lewis symbol for the other one? Is what? Cl 1, 2, 3, 4, 5, 6, 7, and what? 8. What's outside here? Minus. Now have you not noticed that the atomic cores for cations are also the same as the what? The Lewis what? Symbols. Have you noticed that? Whereas for anions, they are different because you have to represent the what? The dots. Beautiful. Move on to the next one now. The next question says, write the Lewis structure for the ionic compound potassium chloride in the box. Now, it is stated clearly here that potassium chloride is what? Is what? Ionic. Is what? Ionic. Now, we all know what happens in ionic bonding. There's a transfer of electrons from the metal to the what? Non-metal. Now, if you look at this, if you look at it vividly, you can see clearly here that the metal is potassium, right? But non-metal is what? Chlorine, or the chloride ion. So this is the metal and this is non-metal. So by calculation, you can see clearly that the 1 electron that was lost here, are you there? Was gained by who? The chlorine. And that makes it, how many is that now? 8. That is why, if I should ask you how many valence electrons are there for potassium, how many for how many? 1. How many for chlorine? 7. Are we together? If they should combine, the potassium is going to transfer the 1 valence electron to what? Chlorine. Are we together? And that makes it to be potassium plus and what? Chlorine what? Minus. Beautiful. Now, what is the Lewis structure for potassium chloride? It's still this, but you're going to write it together. Now, watch. Lewis symbol, or let me say Lewis structure, be given as what? K plus, you put a semicolon. Put a semi what? Colon. You bring this back here. I have a Cl, 1, 2, 3, 4, 5, 6, 7, 8. And what's outside here? Minus. And you're done. That's the Lewis structure. Write it down. There'll be nothing like drawing a dash because the bond is not covalent. It's not what? Covalent. Did you get that? Beautiful. Move on to the next. Now listen. How does the written Lewis structure for potassium chloride differ from that of hydrogen chloride? Now, before you answer that question, now see what I'm going to do. Now, do this for me. So, how does the written Lewis structure for potassium chloride differ from what? Differ from what? Hydrogen chloride. Now, you draw the Lewis structure for hydrogen chloride. Now, look at it. Do this for me. Do this for me. Do this. H C what? L. 1, 2, 3, 4, 5, and what? 6. Look at what I'm doing. Now, what you have here now is what? The Lewis structure for what? Hydrogen what? Chloride. Now, what is going on here? You are trying to say that this Lewis structure is not the same as the other one because the other one is what? Ionic what? Bonding. While this one is what? Covalent bonding. Now, there is sharing of electron between the hydrogen and the what? Chlorine. Are we together? So you can now see clearly that there is a clear difference between the Lewis structure for covalent bonding and that of what? Ionic what? Bonding. Did you get that? So after drawing, just draw it very small by the side. And you now write short. Are you done drawing this? So after drawing this in that space there, the space you have on V, space on V, the space on V. So now write this down. In potassium chloride, the bonding is purely ionic. In potassium chloride, the bonding is purely what? Ionic. Whereas in hydrogen chloride, the bonding is what? Covalent. Don't write too much. That's all. Don't write too much there. The bonding is purely what? Purely what? Ionic. That is for potassium chloride, and that of hydrogen chloride is purely what? Covalent. I'm sure you know the reason, right? Good. Move on to the next one. So we're now on question number 4. Question number 4 says, construct the Lewis structure model for the covalent compound hydrogen sulfide using the following steps. Now listen, like I said earlier, if you can follow all these steps, here, when I start teaching you Lewis structures, it will just be like we are joking because you understand the concept already. Now let's follow the steps now. Turn to page number 83. I'm on 83 now. Remember, we are trying to consider a new molecule, and the molecule in this case is what? Hydrogen what? Sulfide. Hydrogen what? Sulfide. All right, so now step 1 says the total number of valence electrons in the hydrogen atoms is dash. What is the answer? The answer is what? 2. And that's what? 2. Because you have 2 hydrogen atoms, right? Yes. Write it down there. Put 2 there. It's 2. Now, the sulfur atoms has dash. How many is that? 6. How many is that? 6. So 2 and what? 6. Why? Because hydrogen is in group 1. It has 1 valence electron. How many of them are here? 2. That's 1 times 2, 2, right? What about sulfur? Sulfur is in group what? 6. How many of you do you have here? 1. So the second step says write, the class is rowdy. Hence, the total number of valence electrons, how many is that? 8. 2 plus 6 is equal to what? 8. So that's the total there. So step 2, write the atomic cores for the hydrogen atoms and the sulfur atom in the space below. Because sulfur is the central atom in the molecule, arrange the cores so that the hydrogen atoms are on either side of the sulfur atom. Now, it's as simple as just doing this. Sulfur at the center, hydrogen by the what? Side. That's all. After doing this, you move on to the next step. We are done. Please do this, do this. That's all, that's all, that's all. That's what? All. Yes. Go to step 3 now. Step 3 says, write the atomic cores in the space below. Place an electron pair between each hydrogen and sulfur atom. So I'm writing this now. I'm going to have H, S, and what? H. Now you place an electron pair in between each. You can either do this, watch. That's a pair, right? Or you can decide to do this. H, S, and what? H. Both of them are the same. Are you done with that? If you follow all these steps, you'll be good with Lewis structures, I'm telling you. Lewis structure model for the covalent compound. Write the Lewis structure for hydrogen sulfide in the box, distributing the valence electrons so that all 3 atoms are in accordance with the duet rule, and the sulfur atom is in accordance with the octet what? Rule. Now pay attention here. I know you've heard 2 things that are strange. First one is duet rule, right? Is what? Duet rule. Now, what is the duet rule all about? Now, it's telling you that around the hydrogen atom, you can only have 2 electrons. 2 what? Electrons. So, if hydrogen has 2 electrons around it, it is what? It is what? Satisfied. It is what? Satisfied. So, in all bonding, in all your geometries you're going to be drawing, around every hydrogen atom, there must be just 2 what? Electrons. And that is in accordance with the what? It's duet what? Rule. So, that simply tells you that from what you have here, the hydrogen atom is already what? Satisfied. Because around it, there are 2 electrons. Are we together? So since hydrogen atoms are satisfied, this guy here is called sulfur. It's called what? Sulfur. Is sulfur satisfied? No. Sulfur is going to be in accordance with what? Octet what? Rule. Octet what? Rule. I'm going to be saying so many things. Those elements that are found, somewhere around the 3rd period, let's say the 2nd period, all the 2nd period elements, 3rd period elements, are you there? They are always known to attain what? Octet. Known to attain what? Octet. So sulfur is in the 2nd period. Is it 2nd period or 3rd period? 3rd period. 3rd. Now, it's going to attain octet, right? So meaning that the remaining number of electrons are going to be placed around where? Sulfur. To attain what? Octet. So that simply means I can do this, watch. 1, 2, 3, and what? 4. How many electrons did I have before? How many was that? 8. Have I used up all the 8? Yes. That is 2, 4, 6, and what? 8. I can still do same here. 1, 2, 3, 4. Same. Did you get that? So inside that box, either you do this or you do what? This. You can't even do the 2, just pick one because the box is small. Move on to the next, please. Move on to the next, please. All right. Move on to the next. What number are we? Number what? 5. Number 5. We are going to construct the Lewis structure model for the covalent compound sulfur difluoride using those same steps you used before. Please, the question. Number 1, step 1 of number 5. The total number of valence electrons in the sulfur atom is dash. That is what? 6. Put a 6 there. 6. Can I wipe this? Can I wipe this? All right. So the total number of electrons for the sulfur atom is what? 6. Don't forget, we are considering this. SF what? 2. That is sulfur difluoride. So the total number of electrons for sulfur is how many? 6. How many do you have for the 2 fluorine atoms? How many is that? 14. Are we there? Because fluorine is in group 7, right? How many fluorine atoms are there? How many? 2. 7 times is what? 14. So total is how many now? 20. The total number of valence electrons in sulfur atom is 6. The total number of valence electrons in the 2 fluorine atoms, how many is that? 14. Hence, total number is equal to how many? 20. Good. So the answers are 6, 14, and 20 respectively. Good. Move on to the next one. Arrange the atomic cores for the 2 fluorine atoms with the sulfur atom as the central atom in the space below. In the space what? Below. Now, do the same thing we did before. So, they are simply telling you that sulfur is at the center, fluorine atoms are by the what? Sides. That's all. You are doing just this there. You are doing just this. Step what now? Step I, right? It says, rewrite the atomic cores in the space below. Place an electron pair between each fluorine and sulfur core. What does that mean? I'm rewriting the same thing. I have F here, I have S here, and I have what? F. Place an electron pair. I'm doing this, right? I'm doing this. Does that make sense? Or you can still do this, or you can say F, S, and what? F. That's all. Pick any one and do. Don't do 2. Move on to the next step. Now the next step, we are going to be doing what? Write the Lewis structure for SF2 in the box. Now I'm going to be distributing the remaining valence electrons so that all the 3 atoms will be in accordance with the octet what? Rule. Don't forget that these 3 atoms here are made up of what? Sulfur and what? Fluorine. They are found period 2 and period what? 3 respectively. So meaning that they should attain what? Octet. We have 20 electrons to play around with. 20. Out of that 20, we use up how many? How many is that? 2, 4. That's 4, right? Now, first things first. Now, what are the first things? You have to make sure that all the terminal atoms have attained octet first before you think about the central what? Atom. So it's clear that there are 2 types of atoms here in these structures. The central atom and the what? The terminal atoms. All right. So I want to satisfy all the terminal atoms to make them octets. I'll start by saying 1, 2, 3, 4, 5, 6. That's an octet, right? Because it had 2 around it before, right? So total is how many are? 8. 1, 2, 3, 4, 5, 6, 7 and what? 8. Or I can still say 1, 2, 3, 4, 5, 6, 7 and what? 8. Do the same here. 1, 2, 3, 4, 5, 6, 7 and 8. Same here. 1, 2, 3, 4, 5, 6, 7 and 8. So all the terminal atoms have attained octet. True or false? True. Now, what about the central atom? Has it attained octet yet? Now ask yourself, how many electrons have you used so far? How many? How many? How many? 16. 8 plus 8. So the central atom needs extra 4 to attain what? Octet. And we are on the right track. So if I say 1, 2, 3, 4. Is that an octet? Yes. Can still do the same here. 1, 2, 3 and what? 4. All right. So that's the Lewis structure for sulfur difluoride. Did you get that? Move on to the next. Question number 6 now. We're done with 5. Go to number 6. So turn to page 84. 84. The class is rowdy. Please, can I clean this? Can I clean this? All right. Number 6 now. Number 6, we are considering CH2Cl2. Hey. CH2Cl2 is called dichloro what? Methane. Dichloro what? Methane. Or from what you have, I can call it methylene chloride. That's a common name. All right, it's fine. So let's try this. Now, step 1 says the number of valence electrons in the carbon atom is how many? 4. Is how many? 4. So these are the answers in order. Carbon is 4. The total number of electrons in the hydrogen atom is how many? How many? 2. Because you have 2 hydrogen atoms here. And that of chlorine atoms is how many? 14. Total is equal to how many? 20. I'm done with step 1. I should recap. Beautiful. So how many electrons are there in carbon? How many is that? 4. Because it's in group 4, right? What about hydrogen? How many hydrogen? It's 2 because there are 2 of them here, right? Okay, 2. What about chlorine atoms? How many are they here? 2. That is group 7. 7 times 2 is how many? 14. Total is equal to how many now? 20. That's what I did here. Did you get that now? Beautiful. Next. The next question says, position the atomic cores for carbon as the central atom in the space below and place other cores around it. Now the space I'm seeing there is very small. It's very, very what? Small. Now do you know what I want you to do there? See, you can write it just very small. Now do this for me. See, I want to do this. Carbon here, right? See what I'm doing. Carbon here. Just put H, Cl, and what? Cl. Make it very small. It's fine. That's what we're supposed to do there. So place the atomic cores around, you know. Nice pen that has a very, that the radius, the diameter is very tiny. It should be able to give you something like this. Not big, not BIC, okay? Let's go to the next step. What's the next step? Next step, please. What's the next step? Okay, write the arrangement, joining the cores with electron pairs to form necessary what? Bonds. So you're going to rewrite that in there in step 3. But it's just so bad that the spaces are too small. But now listen, see what I'm going to do here. Listen. Now for III, you can draw it beside here. Look at it. You can draw beside here. Have you seen it? Draw beside the box. Draw beside the what? Box. For III, draw it beside the what? Box. While the final answer will be inside the box. Now, see what I mean here. So beside that box, this is the box for my answer. Final answer, right? This is the box for what? This is the box for IV, right? So beside the box, you want to provide the answer to what? III. And what's the answer to II? Look at the answer here. You have C. What's here? H. What's here? H. What's here? Cl. What's here? Cl. That's what I say you should do. This class is hot. It's okay. Move on to the next question now. So now the final Lewis structure. Listen. For the final Lewis structure, you are going to be distributing the remaining electrons around the necessary atoms to attain what? Octets. Now I'm sure you know at this point that no electrons can go around hydrogen again, right? Because it's already satisfied. So therefore, my final answer will be carbon at the center. I have my hydrogen on top. You can still put your chlorine on top, no problem. Hydrogen here, hydrogen here. I have my chlorine here, I have my chlorine here. And now at this point, how many electrons have we used so far? How many? 8. How many is remaining? How many? 12. Now you discover that if you put 6 more electrons around the chlorine, it becomes octet, right? Because there were 2 already here. So if you put another 6, 1, 2, 3, 4, 5, 6, it becomes what? Octet. That's the final answer there. Okay, let's continue. Now we are now on question 7, right? Question 7, we are moving very fast. Question 7 says, construct the Lewis structure model for the covalent compound carbon tetrachloride using the following steps. Now we are going straight to the point. The total number of valence electrons in CCl4 is dash. Now, can I clean this nonsense here? All right, it's going away. It's gone. Okay, now check this out. We are working with this now. CCl4. That is carbon tetrachloride. You can call it tetrachloromethane. Still the same thing, it's fine. Now, what would be the number of valence electrons total here? Carbon is how many? 4. It's in group 4, right? Chlorine is how many? 7 times 4 is what? 28. So everything gives you what? 32. So you put 32 in the blank there. Move on to the next. The next one says, I can't even see it. Write the atomic cause for the element that seems most likely to be the central atom in the space below, positioning the remaining cores around it. Now listen, pay attention, pay attention. I'm going to teach you this in my normal class, okay? But for now, what you need to know is this, that how do you identify the central atom? How? Now, any atom that seems to be, let me say that seems to be the atom that has a lower electronegativity. A lower what? That atom is going to be central what? Atom. Now pay attention here. When I say lower electronegativity, hydrogen is not what? Included. It's not what? Included. It's not when you see something like this other one we wrote before. You have CH2Cl2. Somebody will say, I know that chlorine has a negativity of 3.0. Look at hydrogen here now. It's about 2.1. Look at carbon, 2.5. I beg, now this guy go to center. You do this. You have 0. You have what? 0. All right? Because on no account can you find hydrogen at the center. Do you get that? Why? Why? Because of what? Duet what? Rule. All right, let's move on now. So based on this particular rule I just gave to you now, there are 2 atoms here. 2 types of atoms. We have carbon and what? Chlorine. So between carbon and chlorine, which element or which atom seems to be the one that it's less electronegative? What's the answer there? Carbon. It's constant that carbon is always at the center most times. Are we there? So therefore I have my carbon at the center, and you have what? Cl, 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 and what? Cl. That is the answer to the next question there, which is, what's that question again? Is that the II? Yeah, so you are doing this. The space is not that. Most times you don't need these values. All what you need is the periodic what? Trends. You get back? Because if you check your periodic table, you have this. Check this out. I have hydrogen somewhere, you have helium here. You have lithium, you have what? Beryllium. You have boron, you have carbon, nitrogen, oxygen, fluorine, and what? Neon. You see this bar? Then you have sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and what? Argon. Now check this out. Elements found at the right corner of the periodic table, they are more negative than the ones at the what? Left corner. Are we there? Because from the periodic trends, we say that electronegativity increases across the what? Period. From left to what? Right. So it is right for somebody to say that carbon is less negative than what? Nitrogen. Are we together? And nitrogen is less negative than what? Oxygen. Am I communicating? That is why if you have a molecule like NO2, you don't need to be told that N will be at the way? Center. Because N is less negative than what? Oxygen. Now in this case, you can see clearly here that carbon is almost somewhere here, while chlorine is at the far right. So therefore, this is more negative than this. You don't need to use those values I gave you, all right? It's okay. Can I clean the board now? All right, sorry. We are now on number what now? Step what? What step are we? Step I, right? Okay, so it's place an electron pair between each of the bonding atoms. There is no time. At this point, you know what to do, right? You are not going to do this. Check. Either you do this, should be, or you put what? You put dash. Or you don't just do the C, Cl, 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 and what? Cl. Follow these steps, I think if I'm treating the Lewis structure to be very easy for us, we need to stress ourselves again. So the final answer is found where now? Where is the final answer found? It's found where? That's step IV. Step IV says, after distributing the remaining valence electrons so that the carbon and each chlorine atom has an electron octet, Write the Lewis structure for CCl4 in the box. Now, in the box, this is what they're writing in the box. Are you with me? You're writing this in the box. C, Cl, 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 and what? Cl. Now, how many electrons were total here before? How many? 32, right? So if I do this, 1, 2, 3, 4, 5, 6. Plus 2, how many is that? 8. 1, 2, 3, 4, 5, 6. That's 8 there. 1, 2, 3, 4, 5, 6, 8. That's another what? 8. And at this point, I have used up all my what? Electrons. We are done. That's the final answer in the box. That's it there. Please, your dots should be very small. No big dots. Carry on. Can we carry on now? Can we go on break? Just for 5 minutes, right? No. No break, right? Let's continue. Now, number 8. For number 8, we're going to be considering this. Look at number 8 here. Watch. COCl2. Shh. I'm going to be considering that. COCl2. COCl, yes. This compound, the correct name should be carbonyl chloride. Carbonyl what? Chloride. Carbonyl chloride. Or you can call it Phosgene. You can call it what? Step 1. Total number of valence electrons in COCl to be how many? C is how many? 4, right? O is how many? 6. Cl is how many? 14. Everything is equal to what? 24. But step 2 now. Step 2 says in this compound, carbon is the central what? Atom. Now, chill. If that particular sentence we are not there, I hope you know that carbon is the central atom, right? So in this compound, carbon is the central atom. Arrange the atomic cores appropriately in the space below. The space there is small, right? So now that's the space there. Now listen, hey, take it to the extreme. Take the extreme because I think the space there is bigger. Now you do this. Watch. Carbon here. Do this for me. Carbon here, right? Now put your oxygen on top. Put your chlorine by the what? Side. I'll prefer this because this arrangement is orderly. Yeah, but if anyone does this now, see, I know somebody wants to do this for me. See, does this make sense to you? I need to make sense to some persons, but it doesn't make sense. All right, let's carry on now. Step what now? Step 3. Add electron pairs to show the bonds between the atoms. Add electron pairs. Now, the pairs I want to add here are going to be this. C, O, Cl, and what? Cl. Now, check this out. I'm going to add this. Tip, and what? Tip. I'm done with my pairs. There's some structures we draw with dots, and they look so ridiculous. You can use dash here. Let's move on to the next. So the next question says, assigning the remaining valence electrons so that each atom has an octet of electrons. Write the Lewis structure for COCl2 in the box. If you have trouble placing all the valence electrons, consider the possibility of a multiple bond between two of the what? Atoms. Between two of the what? Atoms. Shh. You will learn so many things today if you pay attention. Now check this out. Now, I had 24 electrons initially, and I have used up how many? How many now? How many? 6. Now, let's do this here. Please, C, O, Cl, and what? Cl. Now, check. 2, 4, and what? 6. I hope you know by right, I'm supposed to drop all the other electrons around the terminal what? Atoms. My first concern is to make sure that all the terminal atoms have attained what? Octet. Let's try that. So this guy should attain octet. 1, 2, 3, 4, 5, 6. Plus 2, how many is that? 8. 1, 2, 3, 4, 5, 6. That's how many there? 8. What about here? 1, 2, 3, 4, 5, 6. That's how many there? 8. And now if you check, we have used all the electrons. True or false?
Yes.
8 plus 8 plus what? 8. That's how many? 24. So all the electrons are gone. But now let me ask you. All the atoms there, or let me say all the elements there, have they attained octet? Which one has not attained octet? Which one? Carbon has not attained what? Octet. See carbon here. Look at it here. How many electrons do you have around carbon? How many are there? 6. It needs 2 more, right? Yes. Okay. Now listen. Anytime you are done placing all your remaining electrons around the, around the terminal atoms, and one particular atom has not attained octet, probably that atom is the central atom. The next thing I'm going to do is what? I'm going to consider the possibility of a multiple bond. A multiple what? Bond. Now, what is a multiple bond? Is either a double bond or a triple what? Bond. Now, in this case, we're going to be considering the possibility of a double what? Bond. Now, if you check, I'm going to explain this better in my general class. But for now, we are doing the assignment. Now, the best possibility of a multiple bond will exist between carbon and what? Oxygen. Carbon and what? Oxygen. Not between carbon and chlorine. Now, I'm going to explain this concept under what we call formal charges when I start teaching you this. Look at it. It's called formal what? Charge. Formal charges. Now, when we start considering formal charges, you're going to see that after drawing two possible Lewis structures, you will now use the rules of formal charges to decide which one is correct, which one is what? Wrong. Am I communicating? So I don't want us to do that now. It's going to take a lot of time. But for now, from the rules of formal charges, you're going to see that when the double bond is here, it is the best. It is the what? Best. So therefore, to put the double bond here, I'm going to clean 2 electrons from here, and I'll have a double bond. And this becomes the final Lewis what? Structure. Because at this point, everybody is now satisfied. So you have 8 here, 2, 4, 6, 8. Around here, you have 8, you have what? 8. That's the final answer. Write it down. Number 9, we are constructing for SiO2. SiO2. Can I clean the board?
Yes.
So at this point, you should be faster than I am because I'm very slow at this point. Very, very fast. So construct, okay, total number of valence electrons in SiO2 is what? Silicon is in group what? 4. Plus O is 6, right? Times 2 what? 12. Everything is what? 16. Oh, yeah, sharp, put it there, 16. So we have 16 valence electrons there. Move on to the next. What's the next one there? So II says, arrange the atomic cores appropriately. Write the Lewis structure for SiO2 in the box. Use electron pairs to show the bond between the atoms. Distribute the remaining electrons so that each atom has an octet. All right. So for the first box, you have this. This box 1. I have Si, I have O and what? O. All right. So what do we do next? The first thing we do is what we do this, right? This and after doing that, what's the next thing you're going to do? The remaining electrons, you place them around the what? Terminal what? Atoms. And that'll give you what? 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6. How many is that? How many is that? 16 gone. 16 what? Gone. That's for the first box. Let's now move to the second box. Now for the second box, it corresponds to III. It says, if you have trouble, okay, I see right, and I'm waiting for this. If you have trouble placing all of the electrons, consider the possibility of using one or more double bonds in the structure. How many, if any, double bonds are required? What's going on? Now for the second box, this is my second box here. So I've done the first step. I have this, I have this. All right, now, if you check now, check. My silicon atom is found in period what? Period what? 3. All right, so now you know that elements in period 2 down and 3, They usually attain what? Octet. So what's going to happen here? Silicon needs an octet, right? And there are no dots to complete that. Is that not true? That means you're going to consider the possibility of placing what? A double bond, right? Then how many if such? So I'm going to erase 2 electrons from here, and I have a multiple bond here. Does that make sense? I'm going to erase another 2 here, and I have what? Another one here. So how many double bonds did you use? How many? 2. So in that dash, they write what? 2. Because you use 2 double bonds. That makes a lot of sense. Did you get that? If you are with your manual, before the third box, before the second box, you have something like, if any double bonds are required, how many of them are there? On that dash, you write how many? 2. Simple. Then you now draw this final thing here inside the last what? Box. We are done with that. Let's go to the next question. That's question number 10 now. Number 10. Now next. Next question, please. So we are now on question number 10. Question number 10 says, write the Lewis structure for hydrosulfide ion. Please, can I clean this nonsense here? Yes. What number are we now? Number 10. So we are going to consider hydrosulfide ion. Look at it here. HS what? Minus. Now let's go turn to the next page. Okay, sorry, 85. Write the Lewis structure for that in the box. Okay, there's nothing like, okay, turn to the next page, turn to the next page. Total number of valence electrons, how many is that? 8. Write 8 there, write 8. Hydrogen is what? 1. Sulfur is what? 6. Now listen, you're going to see that if a compound is positively charged, for example, check this out. Let's say NH4 plus. Have you seen a compound like this, right? And if a compound is like this now, CO3 2 minus. Check this out. Now for the one that is positively charged, after adding up the valence electrons, are you there? If it is positively charged, you subtract the magnitude of the word charge. Now let me now ask you, how many valence electrons are there in ammonium ion? That is what? N is 5, right? 5 plus 1 times 4 is what? 9. 9 minus what? 1. That's how many? 8. Now if it is negatively charged, you're going to what? Add. Now how many valence electrons are here? How many? 4 plus 6 times 3 is what? 18. That's 18 plus 4 is 22, right? What's the charge here? Minus 2, right? You say plus 2. So how many is that now? 24. Beautiful. So with these 2 points of mine, how many valence electrons are here? 1 plus 6 plus what? 1. Equal to how many? 8. Can I clean this nonsense here? All right. Okay, next. Yes. No, I'm about to draw the Lewis structure now. So go back to page 85. Let's work on the box now. So inside the box, I'm going to be drawing this. H, S, are you with me? 1, 2, 3, 4, 5, and what? 6. How many electrons are here? So how many are here? 8. Now, since this particular species here has a negative charge, it's negatively charged. You can put a small square bracket by the side. Or do you put outside? Minus. Retain that minus outside. Beautiful. In this case, there is no central atom. They are neighbors. They are what? Neighbors. All right. Next. What number are we now? Turn to page 86. 11 says, write the Lewis structure for the covalent molecule N2. That's nitrogen molecule there in the box. Before we attempt that, look at the question under. The total number of valence electrons in N2 is that. That is what? 10. That is what? 10. Nitrogen is in group what? 5. How many of them are there? 2. 5 times is what? 10. Beautiful. Move on to the next. Let's now go to the box. Let's go to the where? Box. All right. For the box, I'm going to be drawing the Lewis structure for N2. So I have N2. So in this case now, what is central atom here? Central atom here is what? Nobody. They are what? Neighbors, right? So central atom is still what? N. Abi? No central atom. So I'm going to do this. Watch. I'm going to do this. N and what? N. You understand, right? So next thing is what? You do this. Place an electron pair first. Is that not true? After placing that electron pair, what else will you do? You can see that almost what are they? Out of 10, I've used 2. How many is remaining out of 2? Out of that, that's 8, right? So if I do this now, watch. If I do this, 1, 2, 3, 4, 5, 6. This guy is octet, right? What about this guy? So what do? Hey, to make everybody happy, you're going to be initiating multiple what? Bonds. So I will initiate the first multiple bond. But before I even do that, I have to share the electrons equally. That's what I'll do first. So I have 8 remaining. I'll say 1, 2, 3, 4, right? 1, 2, 3, and what? 4. So I've distributed electrons equally. So after doing that, what else? What else will I do? I will now make sure that each of them will attend octet. Because they've not attend octet. This is 2, 4, 6. 2, 4, 6. So I will initiate a double bond here first. So it's fine. Is anybody octet so far? 2, 4, 6, 8. This guy is octet, right? What about this guy? This guy octet? No. So I'll clean these 2 here. Another double bond. Is everyone octet now? Yes. Draw that in the box. That's the final answer. Using triple bonds, not double anymore. Yes. So we are done. Let's now go to 87. That's the last page of the assignment. You know what? Hey, 11II there. That thing you are seeing there. That thing you are seeing there is not a question. It's an instruction. It's what? An instruction. Have you read the instruction properly? Can we read it together? It says, complete the following table. Assume that the first 2 pair of elements react to form ionic what? Compounds. And the third, a covalent what? Compound. Refer to a periodic table in order to determine the number of valence electrons for each element. Write the empirical formula down. So we are good to go. Let's complete the table. The table does not have enough space. I hope you know, right? So it says potassium and what? Iodine. Potassium and what? Iodine. Those are the elements that are combining. So what are the number of valence electrons for the 2? So you can write for potassium, iodine. All right. Okay, I have that. All right, so potassium iodine. How many valence electrons are here? Potassium is how many? 1. What iodine? How many is that? 7. I'm done with that. You want to write the total? Did you say that total there? So number of valence electrons can write it respectively. So this how many? This 1 and this what? 7. Let me shift it small. Sorry, I want to just adjust it a little. So 1, 7. So total is how many is that? 8. All right, it's fine that way. It's beautiful. 1, 7. Total is how many? 8. Write that. Move on to the next. Empirical formula of products. Now this is the empirical formula here. Everyone knows that when potassium and iodine are coming together, you have potassium what? Iodide. And the formula is what? K what? I. K what? I. That's the empirical formula of the what? Product. Move on to the next. So the last part is the Lewis structure of the what? Of the what? Product. If you read the instruction properly, the instruction has a lot of hints. You are told that the first two what? Species are what? Ionic. And the last one is what? Covalent. So everyone knows that potassium iodide is ionic. So what's the Lewis structure going to look like? It's going to look like the Lewis structure you do for potassium chloride. Are we together? So it will be what? K plus semicolon. Then you have what? Sorry, I'm not. You write I 1, 2, 3, 4, 5, 6, 7, 8. Square bracket here, square bracket here. What's here? Minus. Number 2 says calcium and fluoride. Wow! Hey. I'm jumping straight to the empirical formula. And the formula is what? CaF2. Write it down. Calcium fluoride. What will be the Lewis structure? Now check this out. Ca2 plus semicolon. Are you there? Then you have F 1, 2, 3, 4, 5, 6, 7, 8. Minus. Then you have this 2. F 1, 2, 3, 4, 5, 6, 7, 8. You have what? Minus. Write it down. Sharp. How many valence electrons are here? Calcium has how many valence? How many? 2. Okay, I'll say 2. Difluoride. It's a lie. I hope you know the fluoride you are seeing. How many of them are there? 2. Are we together? So I think there are 2. How many electrons are how many? 14. Is that not true? So what's my total? 16. Good. Move on to the last. Sulfur chlorine. There's nothing like that. Sulfur chloride. But it's fine. Sulfur chloride. But the main thing here is for you to note that for the sulfur here, okay, for the chlorine here, so I can retain chlorine. Do you know why? Because it's trying to tell you that the 2 atoms are combining are what? Sulfur and what? Chlorine. That's fine. So move on to this side now. What will be the empirical formula for that? It will be what? SCl2. Write it down. SCl2. Write it down. SC what? SCl2. Now it has the same empirical formula as the molecule we considered earlier today. I don't know the number. That's SF2. S what? F2. SF2. Did you get that? All right. So the formula will be what? What will be the Lewis structure? It will be what? You have S, Cl, Cl. We are done. Now, do you know why I'm not explaining this anymore? Do you know why? Because this is same as what? SF2. So go back to SF2. Same thing is applicable here. All right. So how many electrons are here? For the sulfur is how many? 6. 14. Everything is how many? 20. Step now. That's the final question for today. Oh, sorry, for the experiment. Using Lewis structures and a balanced equation comes and bromine what? Molecules. Now check this out. Let's start with the very first one. First one is what? Silicon atoms and what? Chlorine molecules. Hey, so when silicon atoms, Si, when silicon atoms, combine with what? Chlorine what? Molecules, right? Supposed to give you something like this. Say what? 4. So let's balance that equation. Now we have 2 here. Shobi? Sorry. You have 2 here. That's the balanced equation. Now write this down. Sharp. What you're seeing here is similar to the compound we handled earlier today. And that compound is what? CCl 4. Have you noticed that? Carbon is found in group what? 4. And directly under carbon you have what? Silicon. Are we together? Silicon can also form silicon tetrachloride. Am I communicating? And the constituents are going to be silicon atoms and what? 2 molecules of what? Chlorine. Are we there? So therefore, that's the balanced equation. Then how do we represent this equation using Lewis structures? Now listen, if you want to answer that question 2i, you're going to be using this side. Are you there? Because the space here will not what? Contain. So you're going to be writing it here. So you're going to be writing this for the equation. That's the balanced equation. And the Lewis structure is going to be this. Si. Silicon here, what group is it? What group is it? Group what? 4. So you say 1, 2, 3 and what? 4. So it has 4 dots. Plus, look at chlorine here. Now, what is the Lewis structure for chlorine molecule? Which will be what? Cl to what? Cl. This chlorine molecule, right? Just like you have hydrogen, H2. H2 is what? H to what? H. Are we together? So therefore, I have Cl to Cl. Then complete 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now close this bracket here. And what will we put outside here? 2. Because there are 2 of them. Are we together? So move on to the product side. For the product side, you do this. Si, you have Cl, 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 and what? Cl. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we are done with that. Go to the next one. So the next equation we have here is the reaction between lithium atoms and bromine molecules. Atoms and what? Bromine what? Molecules. So a bromine molecule looks like this, right? Now this is going to give you what? Li what? Br. Now remember that lithium is a metal, right? And bromine is what? A non-metal. So the bonding there is ionic bonding, right? Yes. So therefore, balance the equation, you're going to have 2 here. And you have what here? 2 here. That's you're going to have 2 moles of what? Lithium bromide. Alright, so how are we going to write it in terms of Lewis structures? It will look like this. You have Li. Let me return this dot here as the dots. Are you there? So how many of them do you have here? How many? 2. Shebi? Plus Br to what? Br. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's all. That's just all. And that gives you what? You have Li plus, semicolon, Br, 1, 2, 3, 4, 5, 6, 7, 8, minus. So how many of these you have? How many of these you have? 2. Are we together? What about this? How many of these you have here? 2. All right. Li plus 2. Dots where? The dot where? That's the dot now. Now, right? Now go. The empirical formula sense molecules, C2H4 and chlorine molecules. Now the product is C2H4Cl2. Now check this out. So we're going to start from here. We have ethylene molecule C2H4. You can call it ethene. Ethene combines with what? Cl2, right? That gives you what? C2H4Cl2. All right. What's the Lewis form of this? We start by saying C, H, and what? H. H and what? H. That's the Lewis structure for C2H4. There are no dots anywhere. Are you there? Good. Lewis structure is the structure plus Cl to what again? Cl. Are we together? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now this gives you what? This gives you C to C. You have this, 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 and you have what? This. Then you have your H, and what? H. You have your Cl, you have your what? Cl. You have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, and what? 6. That's the final answer there. Yes. What did I not do? What? There are no dots here. But the dots are where? Here. See this number? Good. Unless you want to use dots here. Maybe you want to do this. You get that? But I don't like that. I want to use dash. Because dash tells me that those electrons are forming a bond. Forming a what? A bond. All right. Can we move on to the next one now? The next ones are very easy. It will take us only 3 minutes to finish. Yes, you're correct. Let's continue. For number 2, number 2 says predicting empirical formula. Now it says the empirical formula for the hydride of sulfur is H2S. Is what? H2S. Now what is a hydride? A hydride is a compound that contains what? Hydrogen. Good. So a hydride of sulfur has the formula H2S. Now based on this information, you would expect the empirical formula for the hydride of selenium to be dash and its structure to be dash. Now listen. This question is trying to tell you that sulfur and selenium have similar properties because they are in the same what? Group. They are in the same what? Group. It's just like me telling you that carbon can form a hydride with the formula CH4. CH what? 4. And I want to tell you, silicon being in the same group, its hydride will have what formula? What's the formula there? SiH what? 4. Am I communicating? No difference. So therefore, that question we're going to answer it just like this. Hydride of sulfur is H2S. Central atom is sulfur, we know. So what will be the hydride of selenium? It will be what? Se what? H2. Se what? H2. Or you just write the selenium first. Let me see. That is H2 what? Se. Am I communicating? Yes. Just like H2 what? S. Are we together? So you're writing this in the dash. On that dash, you write H2 what? Se. Good. Can we continue now? Now in the box, you're not going to draw the Lewis structure for the selenium hydride. And that's what? In the box, you have something like this. You have Se, you have what? H, you have what? H. Then you have 1, 2, 3, and what? 4. You're done. Very simple. Is it not simple enough? Then the last question for today. All right. So my answers. I will. Okay, now the last question for today. I mean, for the manual, we are not doing 1-1-1 today. Okay. So we're going to do 1-1 for just 15 minutes. Now, what I'm going to tell you in 15 minutes. The second question here says the empirical formula for the hydride of silicon is Si(H4). Is what? Is Si(H4). Shh. And the central atom is what? Silicon. Based on this information, you would expect the empirical formula for the hydride of tin to be dash. Now that would be what? SN what? H4. That's the answer you're going to write on the dash. Did you get that? SNH4. And its Lewis structure will be dash. So in the box, you have SN, H, and what? H. That's the final word answer.